Early morning, when all of us are busy preparing for the day's activity, a section of people with green masks on their faces are out there on the streets, going door to door, collecting our domestic waste and dumping it into large bins placed at different locations in the campus. At this stage, A to Z organization, a leading provider of waste management services in Kanpur, steps in. It carries away the waste to its recycling plant and recycles it into useful manure. The entire process is a part of elaborate waste management strategy adopted by the institute. While the domestic waste is recycled outside the campus, green waste, mainly comprising fallen leaves, takes two routes. A large fraction of the green waste is handled through composting, a natural and cost-effective way of recycling organic matter. The process is indeed very simple and can be carried out on a wide range of scales in almost any indoor or outdoor environment. In the institute, it is primarily done outdoors owing to availability of large open spaces. The dead leaves are dumped into deep rectangular pits created in open and loosely covered with soil. The fill pits are sprinkled with water and left for few months. During this time, the natural decay process breaks down the organic matter into rich humus-like material. The final product is sieved and used as compost for gardens and flower beds. Another method used for green waste treatment, though on a small scale, is vermicomposting. It is a simple biotechnological process where various species of worms, usually red wigglers, white worms and earthworms, are used for decomposing green waste. In the campus, the complete process is carried out within the confines of a vermicompost plant at the nursery. The unit has 2 storage pits on the left, 6 bins on the right, and 2 large pits in the center. Vermicomposting is a multi-step and a closely monitored process. The stacked leaves are dumped into a bin and left for drying. After a week, the dried heap is shifted to the adjacent bin and sprinkled with water. Water helps in reducing the volume of leaves. The following week, the heap is shifted to the third bin, where a little amount of cow dung is added to it. This stage lasts for about 2 weeks. By the time the process enters the 5th week, the texture of leaves has changed considerably. Now is the time for worm activity. The 2 large pits in the center of the vermicompost unit are used for worm action. Each pit can accommodate 4 wormy beds at a time. A banana leaf serves as the base of the wormy bed. A layer of 3 to 4 inches of organic mixture is spread out on the leaf and earthworms are added over it. Earthworms are also known as composting worms as they are very efficient processes of organic material. The whole process is repeated till a pile of 1 to 1.5 feet is created. The pile is topped with cow dung and left undisturbed for a month depending on the weather conditions. During this time, the earthworm digests the organic material and turn it into vermicompost. The finished product is dark and crumbly with an earthy odor. After sieving, it is used as manure for surrounding areas. This manure has been tested for its high nitrogen content in the institute's laboratory. By using the most eco-friendly alternatives to leaf burning, the institute has gained the status of zero burn campus. Apart from solid waste, the campus generates large amount of liquid waste as well. It was in 1960 when the first concrete step towards liquid waste management was taken. Back then, the entire campus population was concentrated to the north of a distributory running from the east to west of the campus land, while the southern area remained untouched. To manage the generated liquid waste, the entire northern area was divided into 5 zones, each provided with sump wells at strategic important locations. This elaborate system was designed for sewage to flow under gravity. The sewage was collected and transported via a network of sump wells and fed into the oxidation pond on the northern end of the campus, where it got oxidized. This partially treated water was used for horticulture needs of the surrounding area, which has now turned into a pristine orchard. In the last 5 years, about 200 fruit trees have been planted in the orchard, including guava, mango, chiku, and bear trees. Many bird varieties can be easily spotted here, like the kingfisher, woodpecker, and Indian tree pie. The orchard is also frequented by several vibrant migratory birds who keep coming and going. In 2009, the institute took another crucial step in this direction. It installed sewage treatment plants in the campus, thus advocating the 3 R's of the waste management strategy: reduce, reuse, and recycle. Each sump well has one sewage treatment plant that recycles the sewage collected from the nearby areas. As the years passed by, the campus population increased and the southern area of the campus began teeming with life, thus adding to the liquid waste generated in the campus premises. Since technically it was not feasible to pump the liquid waste from the south to north zone, another sump well 10, and an oxidation pond to collect the sewage from it were built near Hall 8. The sewage treatment plants installed at each sump well are biotreatment-based plants. This setup comprises a primary settling chamber, 3 rotating discs also known as rotas, and a lamella zone. The sewage from the adjoining areas flows under gravity and is collected in a sump well. From here, it is pumped into the plant. The first chamber of the plant is the settling chamber, where large particles in the sewage settle down. The sewage is then lifted to the first rotor, known as the lifting rotor. Lifting rotor lifts it further to the aerobic rotor, where aerobic aeration takes place. Aerobic aeration is a process where bacteria act on the sludge, eating away the organic matter and cleaning it. From second rotor, it is lifted to the third rotor, where secondary aeration takes place. It then enters the lamella zone, where heavy particles settle down. To further disinfect the treated water, it is subjected to chlorination. In the last stages of the treatment, water is passed through 2 filters. From chlorination zone, the treated water enters into the breaker tank, from where it is lifted through pumps into the sand filters. These filters remove the suspended particles left behind in water. Finally, the water enters into the carbon filters for final removal of any foul odor left behind. Beside the oxidation pond, another water body was constructed to collect rainwater and used swimming pool water to prevent it from flowing into drains. Today, this water body is used for fish farming and horticulture purposes. Water recycled at each sumpfill is used for gardening and other horticulture needs. Presently, the total amount of recycled water is close to 1 million litres. The samples have been tested by the UP Pollution Board and were found to be satisfactory. Also, regular testing is done in the Institute's laboratories. As per the February 2012 lab reports, the BOD level, which stood initially between 80 and 100, went down to between 7 and 12 after treatment. The COD level had also reduced drastically, thus rendering the recycled water suitable for horticulture purposes. Our ultimate goal is not to discharge any untreated water to drains and maximize the use of recycled water. As the campus population increases, the recycling capacity will be increased. The Institute will endeavour to exceed the requirements of relevant environmental legislation and to improve the standards of environmental management. Well, the future looks very vibrant. The Institute is planning to turn the zone into a recreational park offering a variety of leisure activities like boating and fishing. The area with its scenic beauty and clean water bodies will truly be a picturesque place, providing a refreshing break to the campus residents.